So in today's video I just want to give a brief overview of what's been happening for the last week. So the backup heater has been running the tank and I've got it so it's working at 24.5 to a maximum of 25 degrees. We do seem to still be getting the odd spike coming through, which I can eliminate in the graph. At the moment I'm still trying to work out what's causing these odd spikes. Sometimes the DS18B20s are known to give spikes. So here in the temperature monitor flow, I've added here an extra inject node. The reason I've done this is I want to be able to inject 24.5 into that variable. So that will happen, and I've got it timed to happen 21:30. Now this will have to be changed. At the moment this is just after I've got the ESP32 rebooting, and at the moment it's happening around 9 o'clock. So at times I may have to adjust this figure, but that will send that message through to the ESP32, which will then reset the variable for me. So that is one change I have made. The next change I've made is down here. Now in the previous video I showed you how I could send text messages. Now what I've got here is it takes a reading from the MQTT topic. I've got it checking to see if the value is greater than or equal to 10 degrees or below 23.5 degrees. And then if that's the case, I have it trigger a Python script which sends out a text message. Now I have also put here a throttle node, and that then stops that happening for another 3 hours. So to do the check, all I've got in the, which is a switch node, I've got check is greater than or equal to 10, and I'm checking for a number, and then I do the same but in the opposite, which is if it's less than or equal to 25.5, and here we've set the number as 23.5. If it's between them two conditions, it'll pass the message through, and then this is the throttle, and here I've just put a label as 3 hour delay. It's doing it by time, and here I've set the hours as 3. And obviously you've seen previously how I've done the Python script, and all I've done there is told it, right, send this message out. And that is one of the other features I've done. And here it's just looking for if the temperature is over 29.5 and below 32 degrees, and then that goes to a different Python script which monitors and sends out a text if the temperature is above them features. And the reason I came up with is less than or equal to 32 is that just takes into the account some of the spikes I'm seeing. Now these will need to be adjusted because at the moment this is just going to be a backup heater. So I will set different values once I have the final test completed. But hopefully that's something you can see now working. Now the other thing you can see here is I've already made a start on my ATO unit. And this is just at the moment sending information on the state of the water levels within the sump and the ATO top-off barrel that I use. And here you can see in the node dashboard I've got the ATO here. So at the moment you can see the ATO container has got water in it. The sump low water level is red, so it's below the water level, so it's ready for a top-up. And I've got it connected to a Tunzi pump, and that will eventually, when it comes to the time, trigger and fill the sump back up to the desired level, which I've set at 10 seconds of the pump run at the moment. Then the other one here is a sump high water level, which is another sensor. So if at any point my sump level gets too high, which can only really happen if the 2 return pumps are off, then that will show me as red, and I can set up a text alert if I want for that. So these are the type of things I'm working on at the moment. So hopefully this shows you some of the progress I'm making. I will be adding the code for the ATO to the GitHub page shortly, because I've been working on that, and the original one I've shown, I've decided not to use that sketch. Anyway, thank you for watching.